Okay, a few people have asked me to talk about the graph here real quick. So you can just plug in an X and a Y value. So I'm just going to grab them from up here. I already did, but just to kind of show you too, is you can just copy, so Control C, and if you want to paste it in here, the thing to do is to right click or double click on the mouse pad, and then you go to Paste Special, and you want to paste only the values. So I'm going to grab that volume of the zinc, which came from this column right here, versus the height or thickness. I'm going to do it in centimeters because I think that'll have a little bit more meaning. I'm going to do it in centimeters. Oops, and so you don't want to paste, you want to paste special. So down here, paste values only. Both of those are in there now, and now I'm going to go ahead and highlight the X and Y values. And I'm going to click on the chart, or you can click Insert Chart. Either way works. The nonsense chart that they give you there doesn't make any sense. You want to do a scatter chart, so you got to click scatter, and then you have to click the dots. Okay, and that shows me where those 3 dots are. And I do want to use row 8 as headers. Down here you can adjust the chart title. So we're not going to use this for anything except getting our slope. So I'm going to go down here and click on trend line. It's a linear trend. It looks like it's negative a little bit here, but if we look at the value, I'm going to click Use Equation under Label. So trend line again. If you click None, there's no options, but if you click Linear and then scroll down a little bit, the label here, click Use Equation, and now we see that, I'm going to click Insert, that based on this, it's barely going up. It's going up by 0.104 cubic centimeters. So 1/10 of a cubic centimeter, it's going down for every 1 centimeter of thickness I gain. So effectively, this results in basically a 0 slope. But I can copy that slope here. It's negative 0.104 centimeters cubed per 1 centimeter of thickness. Okay, I do hope that that helps. If you're still struggling with these formulas, let me show you where we got all these formulas from. So again, the mass of the galvanized washer, if I double click on that, you'll notice that we talked about this in class, is the paper and the washer minus the paper, which is exactly how you should have covered it in class. If I double click on this ungalvanized, it's just the ungalvanized washer minus the paper. The mass of the zinc then was just this ungalvanized, or the galvanized minus the ungalvanized, because we took off the zinc with the acid. The radius is just the diameter of the outside washer divided by 2. The radius of the inside circle is just this divided by 2. And then to get the area of the outside circle, I'm going to take pi times j, the radius squared. And then to get the area of the inside circle, I'm going to take the inside circle, square that, and multiply it by pi. And to get the area here, I'm just subtracting the outside circle from the inside circle. To get the volume of zinc, that's a little bit more complicated. We know that for every 7.14 grams, there's 1 centimeter cubed. So if I take the grams and divide it by the density, which is the 7.1 grams per centimeter cubed, I end up with the volume of the zinc. The thickness of the zinc then is just the volume divided by the area, because volume is equal to area times height for most regularly shaped objects. The thickness in nanometers is 10 to the 7th away, because centimeter to nanometer is, or a meter is 10 to the 9th nanometers and 10 to the 2nd centimeters. So the difference is 7 zeros. The thickness in picometers, nanometer to picometer, is just 10 to the 3rd. And the height in particles, of zinc particles or zinc atoms, is just this divided by 134. And you should have figured all of that out using a for every statement on your paper first. And then I just copied and pasted that to the other pieces. So again, I do hope that that helps. Go ahead and put in the comments if you're still stuck on something.